All right, hello everyone. So today we've got a pair of parametric equations, and our goal today with these equations is to eliminate the parameter t and sketch the graph given by those parametric equations. So what I mean by getting rid of the parameter is to try to find a relationship that involves only x and y for these two parametric equations. So in other words, y equals something x or x equals something y is what we're trying to get at. So there's a couple ways of doing that. The first method works as follows. So it's by noticing maybe a relationship or some fact from algebra. So if you look at y equals e to the minus 2t, that's like saying e to the negative t squared by rules of exponents. And the point here is you have an expression e to the minus t, which also appears in for x. So if you were to take e to the minus t here and isolate it, you would get x minus 2 equals e to the minus t. So you would have y equals, and here's what I'm going to do. I'm going to replace the e to the minus t and y with the x minus 2. And you would have x minus 2 squared. Okay, so we have gotten rid of the parameter here. This only involves x and y, does not involve t's. Okay, so again, the basic idea here is that you notice some kind of relationship between some expression in both x and y, like we did here, and you go ahead and try to rewrite that common expression in some form or fashion, and then you solve and replace. That's what it's about. Now, the bad thing about this is that doesn't always come out so easily as it did here. Well, not easily, but not as nice as it did here. Sometimes you have to do something else like solving for the actual parameter t in an equation. We'll get to that in a minute. Now, let's get to the actual graph of this. So when you get rid of a parameter, you can graph this by looking at your knowledge of functions. So x minus 2 squared is a parabola centered at with a vertex at 2, 0. Okay, and your parabola, if you were to graph it, would look something like that. Okay, and here's 2. However, our parabola will not look like that, and here's why. You go back to the given equations. T goes from minus infinity to infinity. So you can replace t with any value here that you want. But the main point here is that this itself is always positive. You can get as close to 0 as you want it to. And essentially it's like almost like saying the minimum value for x is 2. So again, this gets as close to 0 as possible for these values of t. So essentially you're looking at almost like 0 plus 2 for x. That's the smallest value of x. Yeah, e to the minus t is always positive, so you have something that's always positive plus 2, it's going to be bigger than 2, okay? And 2 itself is like the smallest value, but it doesn't reach 2. And on the other hand, y is always positive here, because again, e is always positive. So what does that mean for us? Well, for terms of the thing we drew here, we're only going to draw part of it. And the part is basically that right-hand side, because as I said, the x's would be greater than 2, and the y's are positive, so that's that like branch of the graph, if you want to think about it that way. So you can certainly eliminate the parameter and graph, but you have to pay attention to the domain that's given by the original parametric equations. Okay, so let's look at the same problem, but let's go ahead and try to eliminate the parameter in a different way. And we're going to do this by solving for t. So you'll take either one of your equations. It does not matter here because either one of these is somewhat okay to solve. But let's say I take x. And what I'm going to do is going to solve for t. So first thing I do is I subtract 2 from both sides. So let's show those steps in red. Then I take a natural log of both sides. And ln and e just cancel each other out. So that's why you have that minus t left. And you have ln of quantity x minus 2 on the other side. And I divide by negative 1. So the way this method works is you take one of your equations, you solve for t, and you take what you just got and replace the t in the other equation, in this case for y, with what you got. And you do some math, some arithmetic. Negative times a negative makes a positive 2. And then that too, by properties of exponents, that can come up, by properties of logs and numbers in front, by the power rule, that too can come up as an exponent, E and ln cancel, and there you go, you get the same equation two different ways. Now, there are other instances, other ways of getting rid of a parameter by the relationships. Let me show you one real quick involving like trigonometry. So I'm going to do the same thing with these two equations, x equals 2 cosine t plus 1 and y equals 3 sine t minus 4. So what I'm going to do is I'm going to subtract 1 and divide by 2 on the first equation, so you get cosine of t. And I'm going to add 4 and divide by 3 to get sine of t. And why am I doing this? Well, because I know that cosine squared t plus sine squared of t equals 1. So this would mean that x minus 1 over 2 squared plus y plus 4 over 3 squared equals 1. And another way of writing this is x minus 1 squared over 4 plus y plus 4 squared over 9 equal to 1. And how do I identify this equation as? Well, that is a ellipse that's centered at 1 comma negative 4. So 1, let's say here, and then negative 4 is down here. And the way this works is that you have lengths of the major and minor axes here, semi-major axis, semi-minor axis. I won't get too much into that, but say that's minus 4. So I'm going to go up 3 here, down 3, and over 2 here, and over 2 here, let's say. And so, yeah, so definitely I would try to review what I'm doing in terms of graphing the ellipse, but this is what that would look like. Sorry, no, that's not the best ellipse ever, but something along those lines. However, that, as I said, that's the whole thing, and that's not always the case. As you can see here, I'm restricted from 0 to pi over 2 for t. So what does that mean? That only one branch of this ellipse is going to be drawn. And how do I know which is which part? Well, if you start with 0, you get 3 negative 4. That would be like this point right here. And if you plug in pi over 2 into the equation, you get 1 comma negative 1, so right here. And basically what you're looking at is this branch here, okay? And yeah, you can plug another value for t to verify that. So anyways, we can actually get rid of this stuff, and this stuff, and that's what would be left right there. So that's your actual quote-unquote part of the ellipse that you're looking at, okay? So hope this helps. Thank you for your time.